In this slideshow, I'm going to talk about sample sizes, and always an equation to use. So in this case, the equation is n is equal to, which is our sample size, 1.96 squared, which is the 95% confidence, times the standard deviation squared, which is sigma squared there, times the error rate squared, which is represented by capital E. So I'm going to do two problems in this case. I'm going to do them side by side. The first problem we're going to do, we're going to assume the standard deviation is 20 and the error rate is 4. And the second problem we're going to do is the standard deviation 25 and the error rate is 4. This will give you an opportunity to see how much a small change in the standard deviation impacts sample size. So we start plugging and chugging and multiplying. So in this case, 1.96 squared is equal to 3.84, which is equal to 3.84 times 400 divided by 16. 400 divided by 16 is 25, so we have 3.84 times 25, which is equal to 96. And that's our sample size. Now let's redo the same problem again, but this time we'll use 25 as the standard deviation. We plug in the same numbers in the same spots. So we now have 3.84 times 625 divided by 16, which is equal to 3.84 times 39, which gives us a sample size of 96. Now, when we look at the standard deviations going from 20 to 25, and we compare that with the increase in sample size, we see that the sample size went up a lot more than the standard deviation did. So let me make a little graph of this as well. So we can see as the standard deviation increases, the sample size goes up more. So as an example, let's look at a standard deviation of 15. The actual sample size is 54. If we double the standard deviation to 30, we get a sample size of 216. This means that the standard deviation impacts the sample size a lot, obviously, right? And that's the whole point. The end.